friends, this is Priyanka. Today we are going to solve a problem on stability analysis and root locus technique. In this video we are going to draw root locus. We are going to understand when we have to calculate angle of asymptote, breakaway point, angle of departure and point of intersection of branches with this imaginary axis. We are also going to understand why centroid is not getting calculated. So this is important point and you can apply all these conditions for each and every question. So please watch this video till end. Let us understand what is the given open loop transfer function. So this transfer function is given in the form of G of s into H of s, but here feedback is unity and that's why H of s is equal to 1. So transfer function G of s is equal to k s square minus 2s plus 2 divided by s plus 2, s plus 3, s plus 4. Now what is the first step? So first step is to find out the number of poles, number of zeros and number of branches. So we will move for the first step. So how to calculate the number of poles? Notation is n. So we have to take the denominator in the form of s and we have to equate it to 0 and we will find out its a root. So I will say that s plus 2. Now here whole denominator is equal to 0. So we can say that s plus 2 is equal to 0 and s plus 3 is equal to 0 and s plus 4 is equal to 0. So how we can find out roots? That is s is equal to minus 2, s is equal to minus 3, s is equal to minus 4. That means for these three roots we can say that the number of poles, that is n, is equal to 3. Now in the same way we will find out the number of zeros. So for that we have to take the term from the numerator in the form of s and we have to equate it to 0. So s square minus 2s plus 2, that is equal to 0. So I will write here separately because this is the second order equation and we have to find out the roots. S square minus 2s plus 2 is equal to 0. Now we will write the equation to find out the roots, that is in the form of ABC, that is minus b plus minus under root of b square minus 4ac divided by 2a. Now what is this ABC? So coefficient of s square, that is 1, that is a, coefficient of s, that is b, that is minus 2 and c is plus 2. Now I will put the value. So here minus b, that is minus 2, that is 2, plus minus b square, that is under root of b square, that is 4 minus 4ac. So a is 1, c is 2, that is 8 divided by 2a, that is 2. So if I simplify this, now 4 minus 8, that is minus 4. Now we will take here the term under root of minus 1, that is equal to z. So what is the answer for the square root? That is 2 plus minus under root of 4, that is 2. And for this under root of minus 1, that is z divided by 2. So if again I simplify this, 1 plus minus 1z. So this is the root. So if we say that there are two roots, that is 1 plus z, 1 minus z. So if I write here, these are the two roots. So for these two roots from the numerator, we can say that number of zeros m, that is equal to 2. And how many number of branches? So number of branches, that is equal to number of poles and that is equal to 3. Now we will plot these poles and zeros. So remember, for poles I will use this cross sign and for this zero I will use this sign. Now how many number of poles? 3. Where is the location at these roots? That is minus 2, minus 3, minus 4. So for that first we have to plot this S-plane, which is the combination of real axis and imaginary axis. On this real axis we have to plot on the right hand side positive number, that is 1, 2, 3 and so on. And on the left hand side minus 1, minus 2, minus 3 and so on. Vertical line is the imaginary axis. So we have to plot the numbers in the form of z. On this upward side we have to take positive numbers, that is z, 2z, 3z, and in this downward direction we have to take minus z, minus 2z, minus 3z, and here origin is there, that is 0. Now we will plot the poles and zeros. So how to plot? Now poles are minus 2, minus 3, minus 4. So all are real numbers, minus 2, minus 3, minus 4. Now 0. 0 is at plus 1 plus j and plus 1 minus j. So plus 1 is real number and it is the combination of real number and imaginary number. So we have to use the scale. So for this plus 1 plus j, so here is j. So if I extend this horizontal line and vertical line, we have to select the point of intersection. So at this point of intersection, this is the point, and now we will show here with the sign as a 0. Then in the same way, in the downward direction also, we have to take this horizontal line and vertical line, and here is the point of intersection, that is 0. So these are two zeros that we have to plot. Now we will move for the next step. So what is the next step? We know that the branches originates from the open loop poles and terminates to 0, and remaining branches terminates to infinity. Now for this question, there are total 3 poles. Out of 3 poles, 2 branches that will originate from the two poles will terminate to 2 zeros, and remaining 1 branch that will terminate to infinity. So we can say that for this question, number of branches terminates to 0, that is equal to number of zeros, that is 2. So we have to write here 2. And number of branches terminates to infinity, so remaining 1 branch only that will terminate to infinity. That is our second step. Now we will move for the third step. Now we have to find out the range of points which is the part of root locus. So what is the rule? So we have to find out the range for which total number of poles and zeros to their right hand side is equal to odd number, and all this range of point is the part of root locus. Now we will use here the trial and error method. So how? If I take any point in between 0 to minus 1, I will select here the random point. To their right hand side, how many number of poles and zeros? So we have to add total 2. Now this 2 number is even number, so this point does not lie on the root locus. So in the same way, in between minus 1 to minus 2, for any point on the right hand side there are 2 zeros, so we have to ignore that. Then again, if I take in between minus 2 to minus 3, so any point in between minus 2 to minus 3, on the right hand side there are total 3 number of poles and zeros, that is the odd number. So we can say that in between minus 2 to minus 3, all the points are the part of root locus. So I will say that this is the range in between minus 2 to minus 3. Then we will move for minus 3 to minus 4. So suppose I will take any random point. So on its right hand side there are total number of poles and zeros are 4, that is even number. So in the range of points in between minus 3 and minus 4 is not the part of root locus. Now if I take any point after minus 4, then on its right hand side there are total number of poles and zeros, that is 5, which is odd number. So all the points after minus 4 are the part of root locus. So minus 4 to here minus infinity. So I will write that minus 4 to minus infinity. Now if we observe, we have to write the range. So what is that range? That is the range of points for which total number of poles and zeros to their right hand side is equal to odd number are the part of root locus. So range is in between minus 2 to minus 3 and minus 4 to minus infinity. Now I will show this range of points which is the part of root locus with the help of black marker. So minus 2 to minus 3, and after that minus 4 to infinity. Now I will tell you for this question why we are going to calculate angle of asymptote and breakaway point. We will understand why we are not going to calculate the centroid. So for this question there is one branch that will terminate to infinity. So So when the branches terminate to infinity, it moves along the asymptote. So here we have to calculate the angle of asymptote. So for one branch that will terminate to infinity, we have to calculate one angle of asymptote. So what is the formula to calculate the angle of asymptote? That is 2q plus 1, 180 degree divided by n minus m, where q is having range from 0, 1 to up to n minus m minus 1. So I will put here the value. So n, that is number of poles, that is equal to 3, minus 0, that is 2, minus 1. So 3 minus 2 minus 1, that is 0. So here we will put q is equal to 0. So when we put q is equal to 0, so what is the angle? Here 3 minus 2, that is denominator is 1. So it is 180 degree. So from this we come to know that asymptote is at an angle of 180 degree. So if I take the angle that will start from this real axis, then it will end on this real axis only. That is, the branch terminate to infinity will move along the real axis. And what is the meaning of centroid? It is the point of intersection of asymptote on the real axis. But here the whole branch that will start from the real pole will terminate to infinity along the real axis only. So we have to select the range of points such that all these points that will terminate to infinity are the part of root locus. So here I have shown after minus 4 there are the all points which are the part of root locus, that I have shown with the help of black marker. So we can say that this is the branch that will terminate to infinity. So for this question, no need to calculate centroid. And this theory you can apply for each and every question. So please remember this point. Now we will move for breakaway point. So why to calculate breakaway point? So breakaway point is the location of point on real axis from where branches depart. So when branches will start from open loop poles, now it will terminate to 0. But when it terminates to 0, we have to check what is the point on real axis from where the branches will move towards this 0. So what is the formula to find out this breakaway point? So for that we have to first take the characteristic equation, and this equation is in the form of 1 plus g of s into h of s. That is 1 here unity feedback system, and therefore we will take 1 plus g of s, that is 1 plus k s square minus 2s plus 2 divided by s plus 2, s plus 3, s plus 4. Now breakaway point we will get by the solution dk by ds, that is differentiating this k with respect to s is equal to 0. Now how to find out this value of k? For that we have to take the help of this characteristic equation. So for this characteristic equation also we will take here the other side, that is 0. And now how to find out the value of k? So for that I will transfer this 1 to the other side, that is to the other side, so this plus 1 will become minus 1. Then I will transfer this denominator to the right hand side, so it will move to the numerator. So after moving to the numerator we will simplify this, that I will multiply with these two brackets. So it will s square plus 5s plus 6, and in the second bracket s plus 4. And then I will transfer this numerator in the form of s to the right hand side, then it will move to the denominator. So here is the value of k, that is s square minus 2s plus 2. Now this is the value for this k. Now again we will simplify this, that is I will multiply with these two brackets, that is s cube plus 5s square plus 6s plus 4s square plus 20s plus 24 divided by s square minus 2s plus 2. Now here minus sign we have to take as it is, that we have to take for this all the terms. Now here final value of k, that is after simplifying this numerator, k is equal to minus s cube plus 9s square plus 26s plus 24 divided by s square minus 2s plus 2. Now what is the solution for breakaway point? That we have to differentiate both these sides with respect to s. The therefore we have to write dk by ds is equal to, we will keep minus sign as it is. Now in numerator and denominator both are having s term. So how to write? That is, we will first take denominator constant, we have to differentiate numerator. So for this numerator I will write 3s square plus, for 9s square I have to take 9 into 2s, that is 18s plus 26 minus. Now we have to take numerator constant and we have to differentiate denominator. So we have to write whole this term in the second bracket. So these two brackets are separate. Now here we will take numerator as a constant and for denominator we have to write 2s minus 2 and divided by denominator square. So this is the form how to differentiate this equation. Now again we will simplify this. Now we will multiply with these two brackets. Therefore if I multiply these two brackets, 3s raised to 4 plus 18s cube plus 26s square minus, so for this minus sign, if we multiply all the term become minus, that is minus 6s cube minus 36s square minus 52s plus 6s square plus 36s plus 52. So for this plus 2 all the term become plus. Now here in this second bracket again we have to multiply all the terms. So for this 2s if I multiply all the terms, then 2s raised to 4 plus 18s cube plus 52s square plus 46s plus. Now here minus, for this minus 2 if I multiply all the term become minus, that is for minus 2s cube minus 18s square minus 52s minus 48. So these two brackets are different, so we have to make here as a square bracket also. Now we will take here denominator as it is, we will continue this minus sign as it is. Now again we will simplify these two brackets, that here only 3s raised to 4 term is there. Now 18s cube minus 6s cube, that is 12s cube. Then for this square term 26s square minus 36s square plus 6s square, that is minus 4s square. Then for the s term it is 52s minus 52s plus 36s, that is minus 16s, and here plus 52. Now for the second bracket also we will simplify all the terms. So here I will make the whole bracket, that is 2s raised to 4 plus 16s cube plus 34s square minus 45 minus 4s minus 48. The bracket complete, and we will write denominator as it is. Now for this step I will take dk by ds, that is equal to 0. So when we show dk by ds that is equal to 0, then only we can calculate the breakaway point. So when I take this 0, then I will transfer this denominator to the right hand side, so it will become 0. I will transfer this minus sign to the right hand side, so it will become 0. So we have to again simplify this numerator, that is 3s raised to 4. Now if I multiply this minus sign inside, then here minus 2s raised to 4, that is s raised to 4. 12s cube minus 16s cube, that is minus 4s cube minus 4s square minus 34s square, that is minus 38s square minus 16s. Now here minus sign, minus will become plus, plus 4s, that is minus 12s, and here plus 52 minus here plus 48. So plus 52 plus 48, that is plus 100, that is equal to 0. So this is the higher order equation and we have to find out the roots. Now these roots can be calculated by trial and error method. So I have written here these roots directly. So these roots are s is equal to minus 2.36, 1.41, minus 3.52 and 8.48. Now we have to check each and every root. Now minus 2.36. So this minus 2.36, suppose it is in between minus 2 and minus 3. Suppose this is the point, then this is the point which is on the range of real part of root locus. So here these points lie on the root locus. Now we will check the other points also. 1.41. So 1.41 is here. So here this point is not the part of root locus. So remember that the points which are the part of root locus I have shown with the help of black marker. Then minus 3.52. So minus 3.52 is also not the point which is the part of root locus. Then 8.48. So this is also not. So all these 3 points are getting cancelled and only one point which is the part of root locus. So we can say that this point is the breakaway point from where branches depart. Now we will understand for this question where we have to calculate the angle of departure or angle of arrival and point of intersection of the branches with imaginary axis. Now if we observe, branches will start from this open loop poles. It will move towards the breakaway point and then it will reach towards the zero. So here when it reaches towards the zero, there is the point of intersection with this imaginary axis. So we have to find out the point of intersection of imaginary axis. Now how to decide whether we have to calculate angle of departure or angle of arrival. Now what is the condition to calculate this? So when the open loop poles or open loop 0 does not lie on the real axis and imaginary axis, and when poles or zeros are symmetric about the real axis, then this is the condition to calculate the angle of departure or angle of arrival. So when the poles are symmetric about the real axis, then we have to calculate angle of departure, and when the zeros are symmetric about the real axis, then we have to calculate the angle of arrival. Now what is the meaning of symmetric about real axis? That means these poles or zeros. Now for this question we will refer here zeros is having the upper portion and lower portion about this real axis should be same. So if we observe vertical distance and horizontal distance for these two zeros about the real axis is same. So we can say that, or simple words we can say upper portion and lower portion should be same. So here these two zeros are symmetric about the real axis, and here the condition is getting satisfied, that is these zeros are not on the real axis and imaginary axis. So for these two zeros, so here 0 is there, that is branch will move from pole towards 0. So here we have to calculate angle of arrival. So what is the formula for the calculation of angle of arrival? Theta A is equal to plus minus 180 degree minus summation of angle made by zeros with respect to reference 0. So here remember that for angle of arrival we have to take first 0. So in between these two symmetric zeros we have to consider one 0 as a reference 0, and then we have to write the formula, that is summation of all the angles made by 0 with respect to this reference 0 minus summation of all the angles made by pole with respect to reference 0. So for this reference 0 we have to attach all the poles and 0. So I will make here the construction. So I will first join this 0 towards 0, then I will join all these pole to the 0. Now here how to calculate these angles. So here is the angle made by first pole, here is the angle made by second pole, and here is the angle made by third pole. So for that I will make here one construction. Now the angle should be made from this real axis. So I will join here one point that is passing from 0 on this real axis. So here all these are right angle triangles. So I will say here theta 1, theta 2, theta 3. So how to calculate theta 1? So in this right angle triangle, if I write tan of theta 1 is equal to opposite side by nearby side. So opposite side means what? So opposite side, that is we have to take this total height. So this total height is from 0 to 1j, that is 1. And nearby side is from, here this total distance from 0 to minus 2 is 2, and here we have to add this 0 to 1, that is total distance is 3. So we can say that tan of theta 1 is equal to 1 by 3. Then tan of theta 2 is equal to, so in the same way this is the angle theta 2, so here is also right angle triangle. So this total distance 1, 2, 3, 4, that is 4 units, and this vertical distance is 1, that is 1 by 4. And tan of theta 3, so in the same way from this third pole 1, 2, 3, 4, 5, that is 1 by 5. Now we will calculate all this distance with the help of calculator, and here for this 0 to 0, here the angle is 90 degree, because from this horizontal line we have to calculate the angle. Now I will take here tan inverse of 1 by 3. So here 1 divided by 3, and we have to take shift of tan, that is tan inverse 18.43 degree. So here theta 1 is 18.43 degree. So I will write theta 1 is equal to 18.43 degree. Now in the same way 1 by 4. So 1 divided by 4, that is 0.25, and shift of tan inverse 14.03. Then theta 3 is 1 by 5. So 1 divided by 5 and shift of tan inverse, that is 11.30 degree. So these are the three angles, and this angle is also there. So we will put here the value plus minus 180 minus, so here in the bracket we have to write 90 minus, in the bracket we have to take summation, that is 18.43 plus 14.03 plus 11.30. So if we calculate this, so 90 minus, we have to take all these summation in the bracket, we will take as it is 18.43 plus 14.03 plus 11.30, 46.24. So here whole answer is 46.24, and here plus minus 180 minus. So if I take plus 180 minus 46, then I will get 133.76 degree. So here is the answer. Or if I take minus 180 minus 46, so here -226. So 226 point minus 226.24 degree. So here we have to take any one angle. So these are the two angles for this reference 0. So we have to take this, and I will consider this angle as a 133 degree. So how to take? Now I will draw here one horizontal line, and here this 0 as a center. Now from this horizontal line I have to take in this upward direction, I have to measure the angle, because this is positive angle 133. So for this 133 we have to mark here one point. Now if I mark here one point, I will join this point with this 0. So here this is the angle of arrival. So remember, this is the angle of arrival. Now in the same way we have to draw here one angle. So how to draw? We have to just oppose this, or we have to change the sign. That is, instead of plus 133 we have to take minus 133.76 degree or 226.24 degree. That means we have to just change the sign. So suppose I take minus 133, then from this horizontal line we have to measure the angle from the downward direction. So here 133, so here from 0 to 133 we have to mark here one point. Now I have to join this 0 and this. So this is also the angle of arrival. So here we have to take the angle of arrival because the zeros are symmetric about the real axis. Then we will move for the point of cross section of branches when they are moving from these poles towards 0. So how to calculate this? So we know that we have to take the Routh criterion. So for that we have to first write the characteristic equation, that is 1 plus g of s into h of s is equal to 0. So here we have to take here 1 plus k s square minus 2s plus 2. Now I will simplify here. I have multiplied here two brackets, that is s square plus 5s plus 6 in the second bracket s plus 4 which is equal to 0. So we have to simplify this. How to simplify? We have to transfer this denominator towards here and we have to take the combined denominator for this one also and for this also, and here is equal to 0. So at the same time I will transfer this denominator to the right hand side, then it will become 0. So what is the simplified form? So again I will multiply with these two brackets, s cube plus 5s square plus 6s plus 4s square plus 20s plus 24 plus, now I will multiply here k also, that is ks square minus 2ks plus 2k. Now we have to write the equation. So for that I will take here s cube, then if I find out this s square, then for this s square here is 5s square plus 4s square and here is k square. So here plus sign is there, so here there is also plus, that is 5 plus 4 plus k, that is 9 plus k. So 9 plus k in bracket s square. Then if I take s, then here 6s, 20s and minus 2ks. So I will take 6 plus 20, that is 26 minus 2k bracket complete s. Then here 24 plus 2k. So remaining we have to write as it is. So this is the characteristic equation, and from this characteristic equation we have to plot the first two rows. So how to plot? For that we have to take the coefficient. So I will take the coefficient. So for the first row, suppose here s cube, s square, then s raised to 1, s raised to 0. Here on the left hand side we have to write, because first element is s cube. So we have to take this order, that is 3, 2, 1 and 0. Now what is for the first row, how to take these numbers? That is, we have to take the coefficients for the first number, then we have to take the alternate number and then alternate number. So alternate number is not there, so here is 1. So I will write 1, then 26 minus 2k. Then for the second row I have to take the coefficient of second number, that is 9 plus k, and then I have to take the alternate number, that is 24 plus 2k. So these are the first two rows, and from this we have to calculate the other elements. Now how to calculate the elements in the third row? So if we observe, we have to make here the cross multiplication, that is 9 plus k multiplied by 26 minus k minus 24 plus 2k multiplied by 1 and divided by this number. So here is this equation, and here second term is 0. Now again, how to calculate the number of rows, that is number in the rows with this s raised to 0. So we have to select this upper two rows. So if I take this whole equation multiplied by this minus 0 multiplied by 9 plus k divided by again this is whole equation. So this equation from numerator and denominator is getting cancelled and remaining is 24 plus 2k. Now we have to maintain all the elements from the first column should have the same sign. Now if we observe, for this first element in the first column is having positive sign, so positive sign, so we have to maintain all the other elements in the form of k, that should also the positive number. So how it will become positive number? So if I take all these numbers in the form of k should be greater than 0, then all numbers will become positive. So if I take 24 plus 2k, that is greater than 0, then 2k is greater than minus 24. I will transfer this 24 to the right hand side. So if I divide on both sides with 2, then k is greater than minus 12. So this is the one number that we have to take. Now if I take this next element, that is this total equation is greater than 0, then we have to simplify. So I will transfer this denominator to the right hand side, then it will become 0, and again we will simplify this. So if I simplify all this numerator, then it will become minus 2k square plus 6k plus 210 is greater than 0. Now again we will simplify. Minus k square plus 3k plus 105 is greater than 0. Now if I take minus sign as a common and it will transfer to the right hand side, then here the term will become less than. So I can either write this equation minus k square plus 3k plus 105 is greater than 0, or I will write, if I multiply here for whole equation with minus side, then k square minus 3k minus 105 is less than 0. Now we have to solve this equation, that is we have to find out its roots. So how to find out its roots? We have equation, that is this is second order equation, minus b plus minus under root of b square minus 4ac divided by 2a, where a is coefficient of k square, that is 1, b is minus 3 and c is minus 105. So if I take here minus minus, it will become plus 3 plus minus under root of b square, that is 3 square 9 minus 4ac. So here a is 1, c is minus 105. So here minus minus will become plus. So 4 multiplied by 105, that is 420 divided by 2. So again we will simplify this. 3 plus minus 20.7 divided by 2. So if I take here, or if I simplify this, that is 3 plus 20.7 divided by 2 and 3 minus 20.7 divided by 2. So what is the answer? That is k1 is equal to 11.8 and k2 is equal to minus 8.8. So these are the two roots. So how to write the equation? When I take 11.8, that is k, this plus sign will become minus, in first bracket k minus 11.8, and in the second bracket k minus minus will become plus, that is k plus 8.8, and we have to write here less than 0. So we can say that here k is less than 11.8, or k is, or we can say and k is less than minus 8.8. So these are the two values, that is we have to take k less than 11.8 and we have to take k less than minus 8.8. To find out the point of intersection of branches with this imaginary axis, we have to take the auxiliary equation. So when we have to take the auxiliary equation, if all the elements in one row in root array are 0, then there is the formation of auxiliary equation. Now if we solve this equation, that is this is the element from this third row, if we solve, then we will get the range of k, that is k should less than 11.8 and k should less than minus 8.8. So suppose I take the value of k, that is 11.8 in this equation, then this equation will become 0. It will become 0 at k is equal to 11.8, because this is the range that is given. There are two numbers. So here second element in this row is 0. That means when we take k is equal to 11.8, all the elements in this third row will become 0, and we can select this, it's a upper row, and we can form the auxiliary equation. So what is the auxiliary equation? That is 9 plus k a square plus 24 plus 2k. So we have to solve this equation. So here this is the formation of auxiliary equation only when we will take the value of k is 11.8. So for this auxiliary equation also we have to take k is equal to 11.8. Then if I take k is equal to 11.8, then what is the equation? 20.8 a square plus 47.6. So how we can find out which is equal to 0? So on the right hand side we have to write which is equal to 0. So how we can find out a square? That is a square is equal to, we will transfer this 47.6, that is minus 47.6 divided by 20.8, which is equal to minus 2.288. So I will take here square root on both the sides. So this is the square root of this minus number. So for minus 1, under root of minus 1, I will take z. and under root of 2.288, that is 1.51. So here S is equal to plus minus 1.512J. So this is the solution for the auxiliary equation, and this solution is nothing but the point of intersection of branches on the imaginary axis. So I will take plus 1.5J. Here is the number, and minus 1.5J. So minus, after minus J, I will take minus 1.5. So these 2 points are the point of intersection on imaginary axis. So now we know what is the angle of arrival. We also know breakaway point. And here this is the third branch, because here from this pole I have to take one branch that will terminate to infinity. So after minus 4, all the points are the path of root locus. Asymptote is along this line, that is at 180 degree along this real axis. So this is the first branch I have to take. Now we will move for the next 2 branches. So here are the open loop poles. So from these 2 poles, the branches will start and it will move towards the breakaway point. So I have to show the arrow from this breakaway point towards the breakaway point. Now from this breakaway point, branches will depart and move towards the 0. Now here is the angle of arrival. So we have to start the branch that will pass through this point on the imaginary axis and reach to 0 along this angle of arrival. Then here also same, that we have to take from here, the second branch will start, it will pass through this point and then it will reach towards the 0 along this angle of arrival. Now we have to show arrow also. So these are the arrow. So here is the formation of root locus.